From section 8.3, we talk about how to multiply two complex numbers in the polar form and how to divide two complex numbers in the polar form. Now in section 8.4, we want to talking about what if I want to find the powers, nth powers of any complex number in the polar form, or the next video we're going to talking about the root form. So here we're going to introducing a theorem called the De Moivre's theorem. It's talking about if I have a complex number, r times cosine of theta plus I sine of theta, which is a complex number in the polar form, and I want to raising the complex number into an nth power, then the De Moivre's theorem tells me I can find it by taking the nth power of the r and cosine of n times theta plus I times sine of n times theta. So we're going to do one example by using the theorem. So I want to find square root of 2 plus I square root of 2 to the fifth power. So first, the question we have is in the rectangular form, square root of 2 plus I square root of 2. In order to use the De Moivre's theorem, I need to make sure my complex number is in the polar form. So first, I need to rewrite the rectangular form to a polar form. So to do the polar form, I know that this is going to be my x, this is going to be my y. And we also have the following formula. So x is going to equals to r cosine of theta, and y is equals to r sine of theta, and then r is equals to square root of x squared plus y squared, and then the last formula, tangent of theta equals to y over x. So for this one, we are going to use those two formulas to find the r and theta. So to do it, we are going to first find the r by using square root of x squared plus y squared. So square root 2 squared plus square root 2 squared, which is 2 plus 2, 4. So r equals to positive 2. Next, we're going to find theta by finding tangent of theta, which is y over x, square root of 2 over square root of 2, which is 1. So theta is going to equals to 45. Okay, so also if we're going to roughly graph it, so the complex number square root of 2 plus I square root of 2 is in first quadrant, so theta equals to 45. Okay, once we have it, we can rewrite the complex number square root of 2 plus I square root of 2 is going to become to the polar form, which is r times cosine of theta plus I sine of theta. So 2 cosine of 45 plus I sine of 45. Now we're going to find the fifth power. Okay, so to find the fifth power, it's the same for raising the 2 cosine of 45 plus I sine of 45 to the fifth power. According to the De Moivre's theorem, that is going to be r to the nth power, so 2 to the fifth power, and multiply by cosine of 5 times 45 degree plus I sine of 5 times 45 degree. Okay, now we're going to punch everything into the calculator. Actually, to find the exact number, so we cannot really punch everything into the calculator. So 5 times 45 is cosine of 225. And 225 is in quadrant 3. So cosine of 45 in quadrant 3 is going to be negative square root 2 over 2. And then sine of 45 in quadrant 3 is also negative square root of 2 over 2. Then when we multiply them, 2 to the 5th power multiplied by negative square root 2 over 2 plus I times 2 to the 5th power times negative square root 2 over 2. When we simplify it, we will get negative 16 square root of 2 minus 16I square root of 2. Okay, so really quickly, how do I got 16? So what I did is I didn't multiply them, but I just thinking about 2 to the 5th power times 1/2, and then keep the remaining negative square root 2 on the side, where 2 to the 5th power says I have 2 multiplied by 2 5 times and divided by 1, so it will become to 2 to the 4th power times negative of 2, where 2 to the 4th power is 16. So that is how I got negative 16 square root of 2 minus 16I square root of 2. And that is the final answer.